Okay, so I guess now I found out that you can't go more than 15 minutes. Good to know. Okay, so back to where we were. All right, explain what the slope of the graph tells you. All right, you're talking about the spring constant. So if I have one that has a spring constant of 2 and then a different one that has a spring constant of 4, what is different about that? Okay, so if I wanted to stretch something a certain distance to here, okay, this weaker spring would only take this much force, whatever that is, okay? But this spring that's stronger, it's going to take this much force, all right? So it's going to take more force to stretch a spring that is stronger than it takes to stretch a spring that's weaker. So what does that mean for the energy? Well, just look at the areas. This weaker spring has this much energy stored, okay? But the stronger spring has, look at how big this triangle is, this much energy stored, all right? So the stronger the spring is, right, the more slope you get on that line, that's going to make the energy stored more, which makes more sense, right? If the spring is stronger and then I popped it back on your face, it's going to hurt a lot more than if the spring is kind of weak and wimpy, okay? All right. This part, you're going to talk about what is the formula for EE and how did you obtain it. So that one's where you should be writing E equals 1/2 kx squared. Okay, and remember this just came from the area. You started with 1/2 base times height and you started filling it in. That's what we did on the last video. Okay, you need to be able to explain that. All right, and how changing these variables can increase the amount of energy stored. All right. If I increase the spring constant, that's what we just talked about. What happens to the graph? The steeper this line gets, increasing the spring constant, that's going to store more energy because that area is going to get so much bigger the steeper that line is. Okay. Also, in the x-axis, okay, fx, right? Let's say I have the same spring. Okay, so here's my line. All right, how is the energy different if I only stretch it a little bit, right? See that tiny area? If I only stretch it a little bit, I'm only getting that much area. But if I stretch it a lot, then I'm getting this whole area, right? So the more you stretch it, the more energy it's going to store, which again makes more sense. If I have a rubber band and I pull it back really, really, really far, you're really scared of it. It's going to hurt a lot when it hits you. It has more energy the further you stretch it back. Okay? All right, and then in the last one, what are some examples of things that can store EE? And then what kind of things can that EE transfer to, right? So you can talk about like pulling back a rubber band. We saw it in the popper. You could talk about a spring. You could talk about a trampoline. You could talk about anything that's stretchy can store EE. Okay, anything that's elastic and has that ability to kind of bounce back is something that can store EE. Okay, so I want some examples here of something, how it stores the EE and then how that EE can transfer to something else. Okay, all right, I think, whoops, that is all.